In this video, I'll discuss public key infrastructure. Public key infrastructure is often called PKI. It's a hierarchy of digital security certificates that are also sometimes called X.509 certificates. These certificates are issued by a certificate authority, otherwise called a CA, and they get issued to a user or a device or an application. Certificates, among other things, contain a unique public and private key pair that are used for things like encryption, decryption, and the creation and verification of digital signatures. With the public key infrastructure at the top of the hierarchy, you've got the certificate authority, or CA, under which you could optionally have subordinate certificate authorities. So for instance, in a large organization, we might have a CA for the company, but we might have a subordinate certificate authority for different parts of the world. Now, under the subordinate certificate authority, we actually have issued PKI certificates for users, devices, or applications. However, take note that the certificate authority itself could directly issue user, device, and application PKI certificates. Now, something that we have to be careful of is the certificate authority being untrusted. If this is a trusted third-party internet CA, such as Symantec, then most software, such as web browsers, automatically trust that signer. However, if you build your own certificate authority within your company, and you issue PKI certificates, for example, to secure an intranet web server, your devices will not trust the signature on that web server certificate. So therefore, there's a bit of extra configuration when you use an internal certificate authority. The other thing to consider is that the top level or root CA should be taken offline and kept offline for security purposes. Now, what that means is that if the certificate authority were to be compromised, all certificates underneath it, which is everything in the hierarchy, would also be considered compromised. So root level or top level CAs should be taken offline. Certificates themselves have an expiry date. This is set by the issuing CA, and it can differ. It might be 1 year, it might be 5 years, it could be 8 years. Either way, upon expiration, the certificate can't be used any longer. So before expiration, the certificate can be renewed so it doesn't have to be completely reissued. A compromised PKI certificate can be revoked, so therefore the certificate can no longer be used. Inside a digital PKI certificate, we have many things, including the digital signature of the signing certificate authority that issued the certificate. There's also the subject identity, where for a user it might be their email address, or for a website it might be the URL to that site. There's also an expiration date within a PKI certificate, as well as, of course, a unique public and private key pair. Additionally, you'll have key usage information that defines how keys within the certificate are to be used. There might also be the location of a certificate revocation list, or CRL. This is usually in the form of a URL. In other words, it's a site where we can pull down a list of serial numbers for revoked PKI certificates that are not to be trusted. Third-party certificates are often trusted on the internet. However, self-certified certificates are not trusted. And that's back to our example of having your own CA within your company. So devices and applications then would have to be configured to trust that self-certified CA. Certificates can also be issued through something called auto-enrollment. And this is often used in a closed or corporate enterprise type of environment. For example, in a Microsoft Active Directory network, we can use group policy to configure auto-enrollment once devices refresh group policy. This way, we have a centralized and trusted way to issue certificates on a larger enterprise scale. Here in my web browser, if I, in this case, go to the Tools menu because it's Internet Explorer, all the way down to Internet Options, then go to the Content tab, I can then click the Certificates button. Now, interestingly, I can see intermediate certification authorities whose signatures are trusted by this web browser. I could also go to Trusted Roots, in other words, the top of the hierarchy. Here I have an alphabetical list of trusted certificate root authorities that can issue certificates. So, for example, if we trust the Baltimore Cyber Trust root listed here in Internet Explorer, then by extension, we trust every certificate issued under that hierarchy. Now, if you connect, for example, to a website that is secured over HTTPS with an SSL or a TLS certificate, your browser will be consulted to verify whether or not it should trust the signature. And if it doesn't, it'll pop up with a message that tells the user that they probably shouldn't proceed to that site because the certificate is not considered to be valid. Notice here that we have import and export options. So, for instance, we could import a trusted root certificate root key that we have created within our own environment. In this video, we discussed public key infrastructure.